Okay, last night for homework you did some problems on various pages, and one of the pages was 791. And on 791, the questions that I saw most people having questions about, problems with, wanted to see more of, were 16, 17, and 18. So I decided to go ahead and do those for you. And of course we did not have time in class since we were doing our review. Number 16 says, explain why the triangles are similar and then find each length. And the length they asked me for is PS. So first of all, you got to know that these little arrow things mean these two sides, these two segments are parallel. If those two segments are parallel, then we have, I'm going to see if drawing all over this is okay, two parallel lines crossed by a transversal right here, and also two parallel lines crossed by a transversal right here. So that means we have two pairs of corresponding angles. This is a pair of corresponding angles. So in other words, the corresponding angles postulate tells me that those two angles are congruent. And this is a pair of corresponding angles. Corresponding angles postulate tells me these two angles are congruent. So that's why I know that these triangles are similar by AA. Okay, so that's how I know the triangles are similar. Then the next thing it asked me to do is to find this missing length. It's really, really important that when you have one triangle inside another like this, that when you compare them, you either take them apart physically or just be very careful to realize that for triangle PST, you're dealing with whole sides of that triangle. X is a whole side PS and 10 is a whole side ST. But the 6 is not a whole side of the big triangle. Okay, the whole side from P to V would actually be X plus 6. And the reason we need a whole side is because 17.5 is a whole side. So if I'm going to compare whole side, and whole side, we need to do the whole side here. We can't just do the 6. Now if I was just comparing this part and this part with this part and this part, I could do that because they're similar pieces of the triangle. But 17.5 is the entire side of the large triangle, so I have to compare it to another entire side. So I can write a proportion between these lots of different ways. I could put X over X plus 6 equals 10 over 17.5, or I could do X over 10 equals X plus 6 over 17.5. That I think is what I'm going to do. And then I cross multiply. Don't forget you're multiplying by all of X plus 6, so you do have to put it in parentheses and distribute. And then this is 60, 17.5x, subtract 10x from both sides, and you get 60 equals 7.5x. 7.5 goes into 60 8 times, and so I got x equals 8. And the way I set it up was so that x is PS. You could also have set it up to make all of PV your x or your variable, and then at the end take all of PV and subtract 6 to get just PS. But in this case I set it up so that when I got x I would have PS. And that's the answer for number 16, excuse me. Number 17. Now this one was a proof, so I'm going to reveal bit by bit. Number 17 said, given CD, well first we got a picture, looks like this. Given that CD is 3 times as big as AC, and CE is 3 times as big as BC. That's what we're given. We're supposed to be proving that these two triangles are similar. So my first step, I just went ahead and gave the given. It's the first thing to say. Okay, so that tells me basically SS. Remember that there are only 3 possible triangle similarity postulates or theorems I can use. I can use SAS, SSS, or AA. So right here, basically I have 2 S's, and the reason I have 2 S's is because if this is 3 times as big as that, and this is 3 times as big as that, they're proportional. The next step is really just showing that, pointing out that they're the same proportion. So I made a proportion. I divided both sides by AC here to show that CD over AC is 3. Divided both sides by BC here to show that CE over BC was also 3. And since I divided both sides in both of those cases, that's division property of equality. So I've shown that they are proportional. Next, there's nothing I can say about AB and ED, so I cannot say another side. But I can say something about an angle, and the angle I can say something about is the vertical angle pair. Okay, so angle ACB and angle DCE are congruent by the vertical angle theorem. So what I have now is side angle side. So I can now say that those triangles are similar by side angle side. Okay, number 18, also asking us to prove something using similarity. We're not really actually proving similarity here. Well, we are, but that's not what we're asked to do. So let's look at that. Number 18 starts out with this picture. And we are given that these pieces of the sides are proportional. Well, actually, I'm sorry. No, whole sides. This side, PR, side of the small triangle, over this whole thing, MR, is proportional to this ratio, this side of the small triangle, over the whole side of NR. So that's the given information, and I'm putting it first. PR over MR equals QR over NR. That's given. So that's basically S and S. Remember, you're looking for either SAS, SSS, or AA. I just got 2 S's with this one. All right, next, I do have a pair of angles that are congruent. It's really just one angle. I have a shared angle. Angle R is congruent to itself by the reflexive property. Remember, reflexive property always says something equals itself or is congruent to itself. So I just got my SAS. 2 pairs of proportional sides and the angle where they meet. So now I can say that these 2 triangles, the smaller one triangle PQR and the larger one triangle MNR, are proportional, or excuse me, are similar by side angle side. Okay, now the definition of similar is that if 2 triangles are similar, all of their angles are the same and all of their side lengths are proportional. So this is what I can use to tell what I've been asked to tell, which is that measure of angle 1, or excuse me, that angle 1 is congruent to angle 2. So definition of similar triangles is what tells me that angle 1 is congruent to angle 2 once I know that the triangles are similar. It kind of feels like CPCTC. I'm sure there's somebody thinking that right now, but remember, CPCTC is about congruent triangles, so we cannot use that here. All right, now don't forget, if you want to review further for your midterm, the review and the key are online for your viewing pleasure, so feel free to go look at those.